Today we will be talking about how to use the confocal microscope and its pros and cons. This is the setup of the entire microscope. Now we will show you how to use the microscope. Firstly, turn on the camera, monitor, fluorescence lamp and DIA lamp. Next, turn on the main power switch, laser, and ensure that the white light LED is stable. Turn on the confocal. The green light will tell that it is on. Click on Confocal C2 on the PC. To turn it off, reverse the order. Before we start, we have to focus the sample with transmitted light. After it is in focus, turn off the transmitted light. Using the off button to the left side of the microscope, switch the power supply for the mercury light.
Next, you need to decide which wavelength of light to use. There are 3 filter cubes to choose from: UV, blue, and green. Depth fluorescence will absorb the UV light and emit blue light through the eyepiece. Fluorescein will absorb blue light and emit green. Rhodamine will absorb green light and emit red. To change the filter, rotate the filter cubes on the microscope. Switch the shutter to the open position. The shutter can be opened and closed from the intensive light box. Both the switches must be in the open position for the fluorescence to work. Change between 10x, 20x, 60x objective lens. Press escape to lower the nose piece and then manually select the objective lens by using the rotator beneath the stage. When using the 60x objective lens, be sure to use the immersion oil. Once you have finished selecting the objective, press refocus to raise the nose piece back up. Remember to adjust the intensity of the light to a desirable level. If the fluorescence intensity is too bright, it will bleach or quench the sample. You can do so by adjusting the neutral density filter on the light bulbs or adjust the knob with filter 1 to 32. This will lower the fluorescence intensity. Now, look through the eyepiece while adjusting the large knobs on either side of the microscope to focus the image. When you rotate the knob towards you, you actually raise the nose piece. Vice versa, when you rotate the knob away from you, it lowers the nose piece. Switch between coarse, fine, or extra fine using the buttons on the side of the microscope.
After you have focused clearly, go to the main tab on the computer and find the sample with the correct observations. To view from eye, select Light Path to iPod. You can also choose to view through the camera or both. Next, go to the OC panel and choose the magnification used. Choose the laser combination if needed. Remember to save the settings if changes are made. To view from camera, click iPod button to find the sample. Remember to remove the interlock. The interlock is a precautionary button. Scanning speed, scan size, interlock speed can be adjusted if needed. Click the scan button, followed by the auto gain button, and capture to save the photo. After the image has been captured, adjust the laser light color by dragging the HV accordingly.
Now, we will move on to the pros and cons of the confocal microscope. Firstly, we will talk about the advantages. The pinhole aperture eliminates out-of-focus light and reduces blurring, increases signal-to-noise ratio, and allows for the optical sectioning of thick specimens. Another feature of the confocal microscope is the ability to carry out Z-axis scanning, which forms a 3D image. The specimen is normally easier to prepare than when using other microscopes. The magnification can also be adjusted electronically, unlike other microscopes. The confocal microscope also has the highest resolution and contrast. Lastly, it can monitor the physiological state of cells. Now, moving on to the disadvantages. The confocal microscope has a lower resolution than camera detection. It may be very powerful, but it has a low scanning speed. It is also limited when used in dynamic tracking studies. Moreover, samples are usually bleached from laser excitation. Lasers also cause damage to the cells, which limits the use in live cell studies. Lastly, it requires specialized computer software and it is highly expensive.
These are some of the differences in the images between confocal and fluorescent microscopy. Confocal microscope produces a finer images with better contrast as compared to fluorescent microscope, as it uses point emission and a pinhole in the optically conjugate plane in front of the detector to emit out-of-focus signal, unlike the wide field system, where the entire specimen is flooded evenly in light from a light source. All parts of the specimen in the optical path are excited at the same time and results in fluorescence being detected by the microscope photodetector or camera, including a large unfocused background part. The out-of-focus light can reduce resolution, and hence confocal images have a better resolution and a higher contrast than that of fluorescent microscopes. Also, the point spread function removes out of focus. The confocal microscope has a steeper motor attached to the fine focus, enabling the collection of a series of images through a three-dimensional object, unlike the fluorescent microscopes, which reveals the cleaner Z-slices. In conclusion, the confocal microscope is unique. Despite its differences and disadvantages, it produces high-quality images that help scientists understand more about what they're studying, making it a better tool. Thank you.